In this video we will review exponents. Hopefully again this is something you're familiar with, but if not, that's why we have these reviews. Now I'm just going to go ahead and dive in with the rules here. So if we have something that is a to the m power times a to the n power, the exponent rule says that all we do to simplify this is that we do a to the m plus n power. Now the key thing to keep in mind here is what we have here is that the base here on both of these terms is the same. In other words, I have a in both of these cases, and then what do we do to the exponents? Well, we simply just add those exponents to get our new simplified expression. So let's look at an example here as well. So let's suppose we had x squared times x to the fourth power. Now this would just be simply x to the 2 plus 4, which is equal to x to the sixth power. Now I am perfectly okay with, on exams and everything, if you start right here, you can go directly and do the addition in your head, of course. But I went ahead and showed it here just because we're reviewing these rules. So the next one here is if we have a to the m divided by a to the n. And as you may guess, it's going to be exactly the opposite of the first rule, in the sense that we're going to get a to the m minus n power. And again, if we do a quick example here, we could do x to the fifth power over x to the third power, which would be x to the 5 minus 3, which would simply be x squared. And again, you can skip that middle step there and just arrive at the final answer. Alright, so let's continue on with our rules here. Number 3. This is the negative exponent rule, which is used quite a bit. So if you have a to the negative n, this is the same thing as having 1 over a to the n. So a quick example of this, we'll just go ahead and change variable for fun. Y to the negative fourth is equal to 1 over y to the fourth. Now another way this is used, and sometimes people don't see this one all the time, so let's look at one more example here for this. Go away. Let's look at 1 over z to the negative 2. So technically, what is this? This would be 1 over 1 over z squared, which this would just be equal to then z squared. What I like to remember with the negative exponent rule is if you have a negative exponent and it's in the denominator, all it does is this moves it to the top and it becomes a positive exponent. If you have a negative exponent and it's, quote, in the top, you would move it into the denominator and you would get a positive exponent then. Very important rule. Then some other exponents rules. Next one is a to the 0 power. So a to the 0 power, some of you might remember, this is that a is equal to 1. Now sometimes we say this is true for any number. That's not quite accurate. This is only true for a not equaling 0. 0 to the 0 is actually not defined, and so we don't really have that. But to kind of illustrate how this can simplify things, suppose we had a, not necessarily complicated, but suppose we had something like x squared minus 3x plus 1 all to the 0 power. Well, since it's in parentheses and the entire thing is to the 0 power, as long as what's inside is not 0, and we'll assume that it's not 0, this would just simply be equal to 1. Alright, let us move on. So the fifth one here, this would be a times b to the m power. And what this property says is that this exponent, in essence, sometimes people use the word distributes. You have to sometimes be careful, but basically this gets applied to both A and B. And you have to be careful because this is multiplication going on here. And when we review some other concepts, maybe like factoring or something, we'll emphasize that again. Key thing is, what is this? This is A times B. So let's look at an example. So an example here, let's say we had 5x to the third power. And I'm doing this one because a lot of times people aren't careful with this particular example, and especially later in the course. I mean, you might say, oh, I know what to do, but later in the course when you're doing some more difficult problems and you encounter something like this, people tend to forget that the 5 is also cubed. So this would be 5 cubed times x cubed, which would be 125x cubed. Now, I want to emphasize again, before we move on, that this is equaling multiplication here. And what do I mean? Let's look at an example here that this property does not work. So if you have x plus 1 squared, we can't use the property. Why can't we use the property? Well, hopefully it comes to you pretty quickly. The reason we can't use this property is, again, what did I say? A and B are multiplied. What is going on here? We have x plus 1, not x times 1. Okay? So make sure that when you're using that property, things are actually being multiplied. Okay, now we have property 6 here. Property 6 is if you have a to the m power, and then this is raised to the n power. What do we do here? Well, in this case, this is simply equal to a to the m times n power. We just multiply the exponents here. So let's look at an example here, and we'll look at an example where we'll go ahead and simplify out a little bit more using some of the previous properties. So for instance, let's say we have y to the fourth to the negative 3 power. Well, this would be y to the 4 times negative 3, which is y to the negative 12th, but then, whoops, sorry about that. But then when we get to y to the negative 12th, we use the negative exponent rule, and we get 1 over y to the 12th. So that would be simplifying it all the way down. Okay, just 2 more exponent rules here. And this next one is really kind of just a rehashing of property 5. It's saying that if we have a divided by b to the m power, this is the same thing as a to the m power over b to the n power. So let's look at an example here. So as an example, let's say we have x over 3 squared. So this would be x squared over 3 squared, which would of course be x over 9. And just like all these problems here, it's okay to skip this one little intermediate step here. The very last property here, which is used sometimes, it's not necessarily used a lot, but we do occasionally use this here, is that we have, well, absolute value of a squared. This is the same thing as the absolute value of a squared, which is also just the same thing as a squared. And the reason is because if you think about what absolute value does, absolute value, well, technically the definition is the distance from 0 on the number line the number is. But a lot of times people think is it just makes everything positive. So this is saying, well, if you have a number and you make it positive and then you square it, well, if you square a number, that's still going to make it positive. And then you take the absolute value. And then, well, yeah, if we square a number, it's going to be positive, so these things are all equivalent. I won't bother doing an example problem of this. It's pretty straightforward.